Hello students, this is Professor DeLong speaking to you, and I wanted to talk to you today about data types and what is called levels of measurement. Data is information. It is a description of something which might be numerical or it might be non-numerical. The mathematical word for numerical descriptions is quantitative. The mathematical word for non-numerical descriptions is qualitative. The first refers to the quantity of something present, and the second refers to qualities of something present. Consider the image of the dog shown above and look at his paws. The dog has 4 paws. That's quantitative information. The dog has white paws. That is qualitative information. Any information about the dog that is numerical, his weight, the number of eyes he has, the width of his collar, etc., is quantitative information. Any information about the dog that is not numerical, the color of his nose, the color of his collar, whether his eyes are open or shut, etc., is qualitative information. When we make the split between quantitative data and qualitative data, some examples will help us to keep them in mind. The scores on an exam, numerical, that's quantitative. Shoe size, that's numerical, it's quantitative. Weight, again, numerical, so it's quantitative. Time needed to cook a dinner, that's a number of seconds or minutes, that's quantitative data. Qualitative data would be like gender, that's not numerical, that's female or male. Hair color, that's not numerical. Names of students or names of anything, that's qualitative data. Taste type, salty, sweet, bitter, whatever, that's qualitative data. If we differentiate between discrete and continuous quantitative data, then discrete data is not subtle data. It's data that can only take on specific numerical values, and examples include shoe size, the number of sisters that you have, the number of cars in a particular parking lot, the number of hairs on a person's head, the number of grains of sand on a beach. Now, however many of each of these things there is a specific numerical value for it. On the other hand, continuous quantitative data, is data that can take on any numerical value. Examples include weight, the length of a candle in inches, the temperature in Fahrenheit, the distance from your right eye to the computer screen, the time required for a person to run a mile. Now, when you think about the difference between these two, think about a jump in value. Let's look at shoe size and weight, the first example on each list. If you are going from a size, let's say 9 to a size 10, you make the jump instantly. You go from 9 to 10. You do not pass through the intermediate values. On the other hand, let's suppose that you are gaining weight and you go from 179 pounds to 180 pounds. Well, you didn't just make the jump. You actually passed through all the intermediate weights. At some point, you were 179.1 pounds. At some point, you were 179.2 pounds. At some point, you were 179.7938146 pounds. In order to get from 179 to 180 pounds, you had to pass through all the intermediate values between 179 and 180. That is what marks continuous data. Data can also be categorized by its level of measurement. These levels of measurement are nominal, ordinal, interval, and ratio. That is from the least specific to the most specific. To remember these, I keep in mind the acronym NOIR, which is French for black. I'm a fan of film noir, a genre of films from the 1950s. You can make up your own memory tool for this, but to me, noir always sticks in my mind. Here's a way that we can actually determine whether data is nominal, ordinal, interval, or ratio. Notice that it's a flow chart, and you can just follow the flow chart to determine what type of data you've got. So, What type of data is temperature in degrees Fahrenheit? Well, let's go through the flowchart starting at the upper left. The order of the data values is indisputable, so you know the meaning of 1 degree Fahrenheit, 2 degrees Fahrenheit, 3 degrees Fahrenheit, and so on. The data values have a fixed unit of measurement, degrees, yes. Does the zero value mean nothing? Does the zero value mean there is nothing there? Now the answer to this for Fahrenheit is no, because Fahrenheit measures temperature or heat. Now, when you talk about 0 degrees Fahrenheit, that does not mean that there is no heat. It means that the temperature on this arbitrarily constructed scale is 0. What type of data is the current standings of baseball teams in the National League Eastern Division? Well, the order of the data is once again indisputable. If the Mets are in first and the Cardinals are in second and so forth, first, second, third, fourth, these are actually indisputable. We can actually determine the order. Now, do the data values have fixed units of measurement? Okay, the standings in the National League East, that's just a list of data values. That does not have any units of measurement. It's just an ordering in terms of which team is first, which team is second, which team is third. That is an ordinal variable. What's an example of a ratio variable type? It would have to be quantitative, and it would have to be such that 0 meant the complete absence of that which is being measured. The weight of gold in ounces that I currently own is an example of a ratio variable. The ordering of the weights is indisputable. 1 ounce is less than 2 ounces, for example. The measurement unit is fixed. We're measuring in ounces. And if I own no gold, the amount that I have is 0 ounces. 0 means nothing. I have no gold in this case. That is a ratio variable. Another way to think about ratio variables is that if you double the value, the numerical value, do you get twice as much stuff? So if I have 10 ounces of gold and I double that to 20 ounces of gold, does that mean that I have doubled the amount of gold? Yes. Think back to the example of temperature in degrees Fahrenheit. If it is 10 degrees Fahrenheit, and then I jump it to 20 degrees Fahrenheit, is there twice as much heat? The answer to that is no. Once again, we're on an arbitrary scale that is measuring temperature. This is just an example, of course, to the types of data that we've got and the level of measurement. So let's get started with our actual work, and I will see you in class. Bye for now.